Welcome to another Spring Knowledge Transfer event. And thank you all for joining us today alongside United Utilities, who will be taking us on a journey through their Ofwat funded biopolymers in the circular economy project so far, including how it works, the processes they've followed, and the lessons they've learned so far. For those of you who aren't familiar with Spring, we are the Centre of Excellence for Innovation in the UK and Ireland, and our main objective is to enable effective delivery of innovation and collaboration by creating centralised intelligence for both water companies and suppliers. Our mission is to attract, connect and support innovators across the industry to accelerate transformation. And it's great to see the power of knowledge sharing already coming to life, with Northumbrian Water having recently adopted a 3D printing solution, which was actually originally shared by United Utilities in a showcase last year. Northumbrian Water are now progressing plans to 3D print the UK's first underground asset, 3D printed in situ, a brilliant example of how knowledge sharing, especially in the open and honest way that you knowledge share with us, can lead to further innovation across the sector and de-risk the investment side of innovation as well. This work has created a clear shared view of the sector's needs too and paved the way for faster and more aligned adoption. And that's exactly why we facilitate and host knowledge transfer events such as today. Through knowledge sharing, Spring supports the transfer of learnings from an innovation project to the wider sector, creating project legacy that helps innovators to identify and adopt the right solutions at a greater pace. So last year, we actually partnered with Ofwat, the economic regulator for England and Wales, to build a view of what best practice knowledge sharing looks like. We brought together senior leaders and innovation managers to design a vision for knowledge sharing that agreed on what it is we're trying to achieve. And what we are trying to achieve is a world-class knowledge sharing culture. And what does that look like for the sector? So I'll take you through them now. So the 6 principles we created were: number 1, learn from what already exists before committing to innovation projects. So to aid this, we created the Spring platform, which hosts a multitude of project case studies aligned to the priorities laid out in the Water Innovation Strategy 2050. We are also working on other tools to ensure innovation intelligence is easily accessible to the sector. The second is to target innovation insights to the right audience to meet our objectives. So, for example, today, do we have the right people on this call who can take action on the knowledge within their own organisations? Number 3 is that insights are regularly shared through multiple channels from day one of the project. So historically, knowledge sharing has always happened at the end of a project, and we're really trying to move towards a model where we share from day one. Number 4 is that sector knowledge is open and centralised. So we want to make sure that we're all being open and honest when it comes to the knowledge from innovation projects. We want to make sure it's all in one place too, i.e. Spring, because fragmented knowledge makes it very difficult to engage with and learn from. Number 5 is that insights from both innovation successes and failures are shared. As we know, the lessons learned from failures and challenges are just as important as the lessons of success. And we'll hear about some of these from our presenters today. People are empowered to receive and embed lessons from external sources. So Spring and the presenters on this call can all share knowledge, but we want to make sure that the receivers of this knowledge actually have the resource and capacity to make that required change and to take action on the knowledge that was shared. So back to today, I'd just like to give a warm welcome to the audience members who are joining us live. We are joined by the UK and Ireland water companies, supply chain, academia, and plenty of overseas colleagues too. So welcome to the call and thank you so much for joining us. As always, we'll be including a poll during this event to gain your thoughts. Answering our poll is one of the most impactful ways you can help us make sure these events are providing value to you, your organisation and the wider sector, and that these showcases are supporting faster adoption of solutions. Your insights not only help us understand the actions that you plan to take on the knowledge share today, but if there's anything more we could have done or shared to ensure successful transfer of the key insights from projects. We'll launch this poll at the break, so please do make sure to submit your answers when it comes through. And we'll also launch it again at the end for those who didn't get a chance to answer during the break. At the end of the session today, you'll also have a chance to ask the project team any questions. So make sure you do keep putting your queries in the chat throughout today's presentation. So I'm just going to run through the agenda quickly and then introduce our speakers before we kick off. So we'll start off with a little bit more about circular economy at United Utilities. Then we'll hear more about biopolymers in the circular economy. We'll hear from Resell. We'll hear from Resell on salvation and how it works. Then we'll have a quick break and we'll come back to hear more about the Cellforce pilot trial, the next steps before going into our Q&A. Slide 5. Apologies. So the speakers, we are starting to hear from Sarah Biddulph, who is ESG Reporting and Business Improvement Lead at United Utilities. We'll hear from Richard Clark, Programme Manager at United Utilities, Yumi Flapper, Technical Manager at Resell, Francesca McKendrick, Engineering and Project Manager at United Utilities, and finally Bart de Ruyter, Process Engineer at Certec. So without further ado, I'll now hand over to Richard to talk us more through, I'll hand over to Sarah to talk us more through biopolymers and circular economy at United Utilities. Thank you.
Good morning, I'm Sarah Biddulph, ESG Strategy Manager at United Utilities, and I'm delighted to set the scene today for this spring showcase by outlining our approach to responsible business and explaining how we've embedded circular thinking at United Utilities. At United Utilities, we provide water and wastewater services for around 8 million people. So I think at this point it's worth reflecting that our core activities touch on every point of the water cycle, which I think in itself is perhaps the best example of circular principles. So our company purpose is to provide great water for a stronger, greener and healthier Northwest. Our purpose highlights how environmental, social and governance considerations are integral to everything that we do. To deliver on our purpose, we've identified 6 strategic priorities that are aligned to the stronger, greener and healthier elements of our purpose. These priorities are our key long-term drivers and how we create value. Everything we do is aligned to one of these themes, and the way we do things is typically aligned to the principles of circular economy. So I use this infographic in internal briefings at United Utilities as a way to explain circular economy approach and bring it to life with some examples. So why is it important at United Utilities? Well, circular economy can build long-term resilience as well as generating business and economic opportunities. It's also an enabling step in performance for our customers, communities and the environment, and it drives partnerships to share innovation and resources. On the right there in the blue boxes are the examples, just a few, of how we do circular economy at United Utilities. So I'll just take you through them now. We minimise waste from our water and wastewater operations to promote a circular economy. The sludge digestion produces biogas, and in partnership with Levidian, we have also been trialling Loop, a technology that uses biogas to create hydrogen and graphene. And as you know, graphene has multiple applications and uses. Our rainwater management strategy includes initiatives that capture, remove and slow rainwater to impact the rate at which it enters our sewers. But this also provides us with opportunities to improve biodiversity. It creates green spaces which are great for human, mental and physical health, and it makes communities more resilient in the face of climate change impacts. Our peatland restoration and woodland creation programmes also help to boost biodiversity, are beneficial from a carbon perspective and deliver wider benefits to protect water and recreational access for communities. In the last 5 years, we have planted more than 600,000 trees across the region, and we continue to identify suitable locations for further tree planting to meet that 1 million trees by 2030 target. Deploying low carbon concrete on our capital programme, including earth-friendly concrete as part of an Innovate UK project, means that we're replacing Portland cement with lower emissions geopolymer. We believe that operating and procuring in a responsible manner will mitigate risk, build resilience, improve compliance, and ultimately deliver better value for our customers. But we aren't doing this alone. We have a united supply chain approach so that together we can provide great water and more for the North West. Our responsible sourcing principles are structured around ESG issues that are important to us as a business, and one of these principles is circular economy. I'd now like to share a simple but very tangible success story about creating circular change. It evidences our stronger, greener and healthier and united supply chain principles, and it's something that resonates across colleagues at United Utilities. In February this year, we set out to collect and redistribute unused PPE. Collections were separated on whether they could be reused or required. Reused or required disposal. A total of 887 items were collected, 90% of which we recycle sustainably through collaboration with our supplier JK Ross. The rest were washed and made available for reuse in our new PPE store at our headquarters in Warrington. Each time we order new PPE for ad hoc site visits, it costs around £100. Using the on-site store, that saves that cost every time. So the collection of unused PPE helps demonstrate circular economy since it is used at its highest value, materials can be recycled where possible or disposed of sustainably, helping pollution. And it also helps design out waste in the future with the option to use the existing PPE instead of placing new orders. All of those benefits directly link to our greener strategic priority to create a greener future. The removal and out-of-date and potentially unsafe PPE contributes to our great and safe place to work, and the cost savings that I've mentioned mean that we are spending customers' money wisely. So now onto the Spring Showcase and the presentations that demonstrate further innovative opportunities for circular thinking throughout the water cycle.
Brilliant. Thank you very much, Sarah. Hi, everyone. Good morning, good afternoon, good evening, wherever you're dialing in from throughout the world. We've noticed a good few of you dialing in from overseas on the list. So that's brilliant that you've made it along to our showcase today. So I'm going to just take you through the background to the project, the Biopolymers in the Circular Economy project. This is something that I've personally been involved in for over 15 years now with United Utilities, and UU have funded a lot of work, a lot of background work, right from laboratory scale through to where we are today, which is out on site at Blackburn Wastewater Treatment Works, looking at demonstration equipment of how we can extract those biopolymers and move them forward into commercial opportunities for the UK water industry. So where did this all start? Well, I mentioned 15 years ago, it was when we were involved in a project called Endo Sludge. It was an FP7 funded project, so a European Union funded project. And it really just opened our minds up to what was possible, what was available to us with regards to materials within our sludges. And we identified through a mechanical means, through a mechanical grinding approach, that we were able to access what is the intracellular biopolymers within sludge cells, from those microbial cells. And then through that work, we managed to make good friends, okay, across multiple industries, that started to discuss and have a think about how best we could go about using those materials. And that really led us into what has become Biopolymers in the Circular Economy, and what was our Ofwat Innovation Competition Water Breakthrough Challenge 3 proposal. So when we did the proposal, we were bringing the proposal together, and it was around the same time that the Royal Society of Chemistry issued the document which is on the left-hand side of the slide there. So polymers in liquid formulations. And this helped us understand how we could go about maybe removing some of our fossil fuel-based polymer uses with our biopolymer variants. So we started looking at all of those different opportunities to replace those non-sustainable sources. And that helped us develop the triangle, what we call the value triangle, which is on the right-hand side of the slide for you there. And at the base of that triangle, you can see that there's an area that in the water industry, we generally have a good understanding on. I'm not saying we know everything about it, but we have a generally good understanding on it. That's the agricultural use of our biosolids in the agricultural market. So we felt that although this is a relatively maybe low value use for biopolymers at the base of the triangle, it is an area where we could use high volumes of biopolymers. So we thought there's an opportunity there for us all. Secondly, we looked at the middle section on the triangle there, and that's about how we, as water companies, could use biopolymers. So currently we use polymers as polyacrylamides within our dewatering and thickening processes. And we thought, well, maybe we could partially reduce what we use in the way of fossil fuel-based polymers in that context with our biopolymer variants that we can remove from our wastewater and sludges. And then finally, at the tip of the triangle there, you've got the rather higher value uses for our biopolymers, but maybe the harder to reach areas for us as water companies. This is where we need a lot of refinement of the biopolymers that we extract from our wastewater and sludges. And that is things like water repellent coatings, external coatings, so masonry paints and the like, and bioplastics and so on. So harder to reach area for us as water companies, maybe an area and certainly industries that we don't have a thorough understanding of, but if we form the correct collaborations, the correct partnerships, then maybe we could, after we've extracted our biopolymers, find a way into those marketplaces as well. And really not just help ourselves in the water industry decarbonise, help other industries as well. So we formed a collaboration. What you're seeing on the screen there are all of the organisations that have been involved in, or are involved, sorry, in biopolymers in the circular economy. Those above the blue line, if you like, they're all our steering group members. So they're companies, they're organisations that are paying into the project. So 90% of the funding in this £6.8 million project, so around 6.1 million pounds, apologies, is coming from the Ofwat innovation competition. The missing 10% is being paid for by those organisations above that blue line there. So you have other water companies involved. So our colleagues at South West Water and at Severn Trent Water have been helping us along the way, providing us with expert advice as we've been working our way through the different extraction processes that we're looking at for biopolymers. You've got the likes of Cranfield University and Yara, who are helping us look at those agricultural benefits, effectively access to the agricultural market, the biostimulant market, which I mentioned at the base of our value triangle there. We've got Certec and Resell that are helping us look at and have a method for extracting cellulose and then refining that to glucose, and you're going to hear a lot more about that. That's our work package too. You're going to hear a lot more about that from Francesca in a little while, along with Emma and Bart. We've got Haskinen as a key partner. They are providing a method for extracting what they call Calmera, another form of biopolymer from waste sludges. And then finally, we've got Glasgow Caledonian University and Aqua Minerals. And both of those organisations bring very, very key knowledge and experience to our consortium. So Glasgow bring along their expertise in the characterisation of biopolymers, the laboratory analysis that we need to make sure that we understand what we've got, but also what we can use it for. And then finally, we also have Aqua Minerals, who have been key to achieving end of waste status within the Netherlands for the Calmera biopolymer. So our plan is to use that knowledge and experience from Aqua Minerals and bring that to us and see what we can do within the UK to help us on our way to that end of waste status for those different commercial opportunities that we're identifying. Below the blue line are other key organisations which we can't achieve our outcomes of this project without. There are advisory members. There are organisations that have said, look, We can't at the moment provide funding into this, but we absolutely want to be involved and want to help you direct the project along. Okay, so they're helping us from time to time. We're able to ask questions of them and make sure we understand how best to shape our project and shape our outcomes to absolutely maximise the benefit of what we're doing. Because a lot of what we're doing is research, and some of it is more towards the higher technology readiness level scale, and we're out on site with. But when we bring all of this together, it's a nice broad programme for the water industry, helping them move forward. So just below that line, you've got other water companies involved. You've got other key end users, so the likes of Crown Paints. You've got Unilever are up there. We've also got Solenis and SNF who already supply polymers into our industry, into the water industry for thickening and dewatering activities. They're interested in how they can become more sustainable through the use of biopolymers as an alternative raw material as well. And two key late joiners, I'll say, to our consortium have been the Calmera sales and services team. They bring with them an absolute, a wonderfully wide range of knowledge and experience from the Netherlands, where they've been working with the Calmera biopolymer to understand all of those different uses that there are and what we could potentially do within the UK. And then finally, TU Delft, who've done a lot of research in the past around the characterisation and support of both the Calmera sales team and Haskinen. We can absolutely learn from them. So the key thing is we're not repeating what people have done before. We're trying to sweep up all of that background knowledge so that we can move forward into the future as a water industry, accessing those different commercial opportunities and helping others to decarbonise. The project itself is split down into a number of work packages. So work package 1, we look at the Calmera system with Haskinen. This is up at Blackburn Wastewater Treatment Works. We're just at the point of turning that system on now, and then hopefully understanding what yields of Calmera we can get from different sludges that we produce within our normal wastewater treatment process. So that's one means of extraction. The second means is our cellulose recovery and then that glucose development in work package 2. That is what you're going to hear a lot about this morning. That's the main reason for this showcase, and that's when Bart and Emma are going to come in a little while, and they're going to explain what the process is all about in work package 2. And then later on, after the break, you're going to hear from Francesca. She's going to talk about some of the results, some of the learning that we've achieved from the site, from the plant that we're currently running at the Blackburn Wastewater Treatment Works. So work packages 1 and 2, very much exciting kind of science and engineering bit of work out on site. But if we do that, that's all very well. But if we do that and nothing else, then what does it all mean? What do we get from it as a water industry? Because we can have lots of fun taking samples and operating these bits of kit, but if we don't understand where to go with the answers that we get from that on-site work, then we're left with nothing. We've spent a lot of money, a lot of time without answering the real key questions. And that's where the latter work packages come along and help us. So in work package 3, this is really the key hinge point within our whole biopolymers and circular economy programme. This is where we look at characterisation. And by that, we mean a couple of things. What is it have we got? So our colleagues at Glasgow Caledonian University, at Cranfield, our labs here at Lingley Mere in Warrington with United Utilities, and also our colleagues at CPI over in the Northeast, they're helping us understand exactly what we've got. What is the makeup of our biopolymers, whether that be Calmera or whether that be the glucose that we've developed. And once we understand what it is we've got, how much glucose is in there, what the makeup of the material is, we can then start talking about the future and what we need to achieve for all of those different uses that we'd like to use our biopolymers within. It also helps to inform the end of waste application as well and understand exactly what is the information people need to see from us as a water industry when we produce these products. The third thing I'd say about this, what you're seeing on the slide here, is also how far should we go as water companies, and that is a key bit of information that we need from biopolymers and the circular economy. We're starting with the brown, loopy, horrible, smelly stuff on the left-hand side of the slide there, and what we need to get to, ultimately, to use it is the white, fluffy material on the right-hand side. Now, that's going to take a lot of work, a lot of effort, a lot of money to get from one side of the slide to the other. So we need to understand from our project, where is the most appropriate place for a water company to stop refinement and hand it over to somebody else that specialises in that area. So that might be at the beginning, or it might be at the very end. Work package 3 tells us where we should go. Okay, it tells us whether we should go into what we can do in work package 4. So do we have suitable biopolymers to look at what is truly a circular economy use within the biopolymers in the circular economy project? That's for water industry uses. So can we use it as an alternative to polyacrylamides in dewatering and thickening? Can we use biopolymers to help us reduce phosphate within return liquors from our dewatering activities to our inlet works, and therefore reduce the burden on our wastewater treatment processes? And do we see an increase in biogas from the likes of the cellulose that we extract as well? Does that help us and others become more sustainable? So there's a nice bit of what is laboratory scale work in work package 4 around what we do in the way of water industry uses. In work package 5, this is the package being led by Cranfield and Yara. They're looking at agricultural uses, and they're looking at this in 2 ways. You've got the organic mineral fertilizer that Yara already manufacture in pellets. We're seeing if we coat that with biopolymers, are we able to use our fully sustainable biopolymers as a fully sustainable form of phosphate within organo mineral fertilizer manufacture, but they're also looking at it as a biostimulant as well, as a spray for existing plants to see if that helps with growth rates within agricultural systems. And they're doing that within their greenhouse at Cranfield University, but also within field trial, which is one of the reasons why our programme goes out for a couple of years, because we are trying to fit 2 agricultural growing seasons into our project. So the project doesn't actually end till October 27. So we've got a couple of years to run here. And then work package 6, this is the harder to reach area. This is the tip of that value triangle that I spoke about earlier. This is where we're saying to all of those organisations were on the slide there, are there areas as water companies that we can go to, that we can go into, that we can go and help, and yes, maybe get a commercial advantage, but also help to decarbonise as well. Okay, so you've got a few areas where regarding building materials. I've spoken about bioplastics for glucose. There's coatings for tanks to see if we can improve on the thermal retention of tanks and so forth. So lots of different areas that we can look at as organisations within the biopolymers and circular economy consortium that could open up good opportunities for everybody else in the UK water industry. And that's it for me for now. I'm going to hand over now to Bart, okay, who's going to talk to you about work package 2, specifically the cellulose recovery system. Thank you very much for your time, and thanks again for coming along to our showcase. Just need to do that. And that.
Yes, thank you very much, Richard. I'm here together with Ima Flapper to talk about the combination of CellCap and CellForce, which is, as we speak, piloted right now at the wastewater treatment plant of Blackburn. Let's first start with a small introduction. So my name is Bart. I'm a process engineer at Cirtec, and that's how I am involved with the project. Cirtec is a company located in Purmerend in the Netherlands. And then you, Ima.
Yeah, thanks, Bart. So good morning, everyone. So I'm Ima Flapper. I'm the technical manager of Resell. So I'm going to tell you later a bit about the CellForce process, what we have developed, and we are located in the northern part of the Netherlands. But first, I give it back to you, Bart.
Yes, thank you. So we at Cirtec have our technology CellCap, which focuses on cellulose recovery. Cirtec is recently part of Nijhuis Sour Industries, which gives us a huge potential in well, all the solutions we can offer. What we say is we turn words into actions with game-changing innovations and deliver integrated industrial and municipal design, build, finance, maintain, and operate water solutions. So that means that we can deliver designs, we have production facilities, and we are even capable of delivering maintenance and operations solutions in this case. So what are our key activities? So Cirtec is a company that is focused on screening and filtration technologies such as CellCap. We have several products in that range. So that goes from the intensive, which is part of CellCap, but also other screening technologies like disc filters and drum screens. So what we as Cirtec deliver in terms of services is that we go from the very small lab scale testing up until where we realize projects, and we try to assist where we can along the way. But what we're going to focus on today is mainly about the recovery of cellulose from sewage. So what is driving us? So as you can see on the image on the right, the country overshoot days in 2025. I will quickly explain what the overshoot day means, but it's basically the day at which the Earth has reached its max resources that it can generate for that 1 year. And every day or every year, that day is getting closer and closer to the start of the year. And so what we see is that on the 26th of July this year, that overshoot day was already reached. And for the next year, it's prognosed to be at the 5th of July. So that means that we are more quickly reaching those, well, basically using up all the resources that are available on our planet. And one of those resources is paper. Western Europe consumes about 10 million trees yearly for toilet paper, and that is a huge burden on our planet. That cellulose ends up in our sewage, and that's also where we see a huge potential to recover that, and also reduce the amount of deforestation that is required to keep up with our demands as humans. So our focus is to shift away from the waste disposal system that's being used right now. If we look at cellulose fibers within sewage, and we aim to offer a solution that is capable of recovering this valuable resource through a proven water treatment technology. And the technology is CellCap. CellCap is a two-stage sieving technology, and apart from, or what separates this from proven sieving technology is the fact that we use a pre-screening to remove other organics from the sievings before we separate the cellulose fibers from the incoming sewage. So where are we present in the current wastewater treatment plant process? So after the sewage enters the coarse screening, that's where we implement our technology as a primary treatment alternative. And the effluent of our system returns to the normal biological aeration systems that are present on many wastewater treatment plants. And what you can see on the bottom left of this slide is that we recover two organic streams, where the left one is basically all the other organics, which we call the residuals, that have a huge biogas potential. And on the right, you see the valuable cellulose fibers that we can put into use in many applications, as Ima will talk about a little later. So what is that? What does CellCap consist of? So CellCap consists of two separate units, which is the first one is called the cell wash, and this one is a outside fed drum filter, which uses a very innovative inlet of the water, which makes it so that the cellulose fibers are not captured on the outside of this drum, but other solids with different shapes and different structures are caught on the outside, and by means of a scraper we are able to remove them, and that makes it so that the filtrate of this system is still contains the cellulose fibers, and which can then go through to the second step where they are captured separately. And that process step is called the intern sieve. It's a rotating belt fine sieve, and by means of cake filtration, we are able to remove all these cellulose fibers from the sewage. And by using cake filtration, we're able to keep up with very high hydraulic capacities, whilst also having a higher removal efficiency, because you can imagine that if you capture, if you have a very fine cloth, that would add more resistance, and then your installation size would also become quite large at that point. So what does that mean for the treatment works? Because after all, it's a primary treatment step. So what we've seen in several pilot studies and references is that we are able to, on average, remove 40% of the incoming solids to the wastewater treatment plant. We filter around a particle size of 400 microns, which is the filter mesh on the intensive. But actually, because of this cake filtration, we're able to go lower or capture smaller particles as well. And that is why we are reaching higher TSS removal rates. Well, that TSS removal rates corresponds to a COD removal rate of 25% on average. And this is mainly particulate, so particulate COD. Well, because that COD is captured within our system, that means that there's less biological load, which needs to be treated by the biological system afterwards. And that can even lead up to a 25% of aeration energy, which is required, a reduction in it. And because there's also less biological load to that system, that also means that there's less sludge that needs to be produced for within that biological process. Here's an overview of what that looks like and what the effects are on many downstream processes. So we see that we have the biology requires less energy. There are less fibers and hairs which clog up aeration modules. There's a reduced amount of sludge production, which leads to lower polymer consumption and less waste. We have a limited impact on biogas production because we remove organic load up front that also might impact biogas production in a later stage. But because we have this residual stream, we sort of counteract that reduction. We see no changes in our sludge settling index, and because cellulose can be put to many different uses, we can even dry it. That also reduces total transport. So very quickly, this is what I meant with the reduction of fibers going through the biology. And you can see in these pictures that it's visibly, that our technology visibly removes these fibers. in the influent, but also in the sludge that is in the active sludge system. So here's a visual representation of what that looks like. So on the left, we have just the rotating belt fine sieve, and where you can see many particles still present on the filter cake, which in the cell cap system have been separately captured, leading to a more pure cellulose fiber fraction and also a organic fraction that we can make biogas out of. And here's what that means in terms of numbers. So compared to other single stage sieving technologies, we are able to increase the cellulose content of that fiber fraction. And also this may lead up and increase the effectiveness of applications that are put, that are making use of the cellulose that we recover. So from this point on, I'd like to invite Ime back, and he's going to talk about the CellForce technology.
Yes, thanks, Bart. So I think it's interesting to see how we can get a high purity of cellulose, but of course also important, what can we do with the cellulose? So I'm going to tell you a bit more about that. But first a bit, why is RECEL doing this? So what we are seeing is that in Europe, 20 million tons of cellulose waste is just discarded, is incinerated, even sometimes landfilled. So a lot of CO2 emissions comes with that, and also with a lot of costs. So we have to see, so we want to improve that to make it into new products. I think this graph, you mainly have seen it. You see on the right part, you see the CO2 pricing, which in 10 years it goes to really high amounts. So that we are looking forward to improve or to remove CO2 emissions, to save CO2 emissions, to make new products from it. And also in the left graph, you can see in 2020 there were a lot of fossil-based products on the market, and in 2050 we want to remove all those fossil-based products by just using bio-based alternatives, but also by recycling, and that's exactly what we are doing. So what about the cellulose waste we are using? So in general, we're using different cellulose waste material. So you can also think about the remaining parts of the paper sludge from the paper industry, about communal waste. But today I want to talk about the wastewater treatment plants, of course. So what's our commitment? So we want to have that 20 million tons, bring it back to the market without being incinerated anymore, to save the CO2 from it, and also to increase or to improve the whole value chain with it. So what technologies do we have? So we have two technologies. So we're starting with the cellulose waste. We have the CellForce technology. With the CellForce technology, we are making sugar. And with the Cellfation technology, we are making fibers. And both products we can bring to different markets. So you can think about the biochemistry, about biogas, advanced ethanol, but also about building materials. So I'm going to tell you a bit more about the processes. So the Cellfation process, so there's why we're making the fibers. On the left part, you can see our first of a kind plant we built in the Netherlands a few years ago. In the concrete building, there's the sieving part of it, what Bart just explained. And on the wooden part, that's the Cellfation process. And we're making here a fiber product which we can bring to the market. On the right part, you can see a scale plant, what we're already working on in the UK with Severn Trent Water, where we have a 5 times higher capacity. So we're already upscaling this process into the market. Then what's the process about? So Bart already told you about the first part, about the grit removal, the cellulose washer, and the Certec intensive, so the cell cap process. Then we dewater the material with the cell press, and then we have a watery solution with high purity of cellulose, but there still contains a lot of bacteria in there. So we have to remove all the bacteria. We do it by hygienization. We also want to dry the material to make it suitable for the market. So then we have a so-called semi-finished product, which we can bring to the market. but most markets have different applications and different questions and demands. So we have a polishing step to improve the quality, to making a fluffy fiber, for example, to making pellets. And then we have the resale products which we can bring to the market. And which markets can you think about then? So we have different markets for it. You can think about the functional additive in the asphalt industry. There it saves that we have a good mixture in the truck, and then we pave it on the road. So then we have a good, nice asphalt. So that's the function of the cellulose in there. We can also make like wood alternatives, like picnic tables, cladding, stuff like that. Also the wall cladding to improve the walls with a sustainable look, and also interior panels. So we can make quite a big range of products already, which we already sell to the market here in the Netherlands. And we're also going to do then that in the UK. Then about the cellforce process. So there's where we have where we are producing sugars, also for the different markets, so for the biochemistry and the biofuels. So there we are working towards the first of a kind process. And that's what we are trying to do. We want to improve it, and at 2027 we want to have it operational. And what's our process about? So we have, of course, the sourcing. So we start with the cellulosic material from the sewage treatment plant. We have a pre-treatment process to improve the quality even further of the cellulose before we do it in our core process. In our core process, we hydrolyze our cellulose into glucose. That we are doing on an enzymatic way with mild conditions, so low temperature and low pH or neutral pH. Then we need the downstream processing to purify the glucose what we are producing, and also to concentrate it to be able to transport it to the different markets. And then we produce a glucose. It's a standard glucose DE95 with just a standard quality what's used in the market already. So what kind of products can we make from it then? So we can think of different products like bioplastics, for example, PLA, PHA, or also BioPE. Polyethylene you can produce like detergents from it, but also more for the fuels. So advanced bioethanol is quite a large market who wants to improve their quality. You can also use it for the sustainable aviation fuels for the aircraft to make it more sustainable. Why is the market now demanding this kind of glucose? That's because if you can also get it from like the sugar beets, for example, but you need land for it. It's also seasonable dependent. So that's also important. And here we use waste materials which can be reused into new products. And then, so where we are coming from with the cellforce technology, we started on the lab, of course, in 2021. We went to the pilot. Then we built our first pilot in 2023. We did it in the Netherlands. We validated it over there, and it works quite well. And we now shipped it to the UK. So Francesca will tell a bit more about that, what we are doing now and what our successes are over there. What I mentioned, we are now working on our flagship plant, and we want to have it operational in 2027. But of course, that's not the end point. We want to upscale it even further because there's a lot demand from the chemical industry to improve this. So in 2030, we want to have our 15 kiloton scale plant. Both are probably located in the Netherlands. So that's what we are doing in the cellforce process. So I hope that was all clear. But if there are any questions, please put them in the chat and we will ask them later on. So I'll give the floor back to Leah.
Thank you so much, Bart and Yumi. That was absolutely great. So as Bart said, we will be going into a bit of a break now. So we have a 10-minute break. So the time is now 10:50. We'll be returning at 11 to hear more from Francesca about the Work Package 2 process and the learnings and challenges that came along with that. We'll then hear a quick summary after that from Richard before launching into the Q&A. So if you do have any questions that occur to you during this break, please do make sure to keep putting them in the chat. and throughout the rest of the presentation too. You'll see here on the break screen there are some barcodes. If you're interested in this showcase and similar things to this showcase, here are some barcodes to our upcoming showcases where you can find more information and sign up. You don't need to go anywhere for the break. Your cameras and mics are already off, so there is no need to go. You can just go and do your thing and stay in the call. My colleague will be putting the poll that I mentioned at the beginning of the call today in the chat, so please do make sure to do that when you get a second during this break or at the end of the session when we pop it in again. Thanks everyone, we'll see you at 11. Hi everyone, welcome back. Hopefully you had a chance to fill in the poll in that break. If not, we will be putting it in again at the end of the session, as I say. So welcome back from the break. We'll now be going into some more detail about Work Package 2 and specifically the challenges that are involved with this piece of work. And we'll hear from Francesca all about that. So Fran, I'll hand over to you.
Hey, hi everyone. So yeah, I'm Francesca McKendrick and I'm going to be talking through a little bit more about the learnings and the outcomes from our Work Package 2 trial that we've got at United Utilities. So I'm going to start just by talking about the trial location, so where we've located the Cellforce pilot plant. We've currently got that at Blackburn Wastewater Treatment Works, so this is one of our larger wastewater treatment works. It serves a population of around 290,000 and it has potable treatment of about 80,000 metres cubed per day. So you can see an aerial photograph there on the right-hand side of Blackburn. We've got our Cellforce pilot plant located just by the inlet channel, so really convenient access for us and easy for us to take crude sewage off the inlet channel and be able to return our liquids back there as well. At the bottom there, you can see a drone photograph of our pilot plant equipment. So we've got the cell cap process that Bart talked through earlier in the blue container on the left-hand side, and that's where all of the cellulose recovery goes on. And then the equipment to the right of that blue container is all for the Cellforce process, where we convert our cellulose to glucose. Okay, so moving on to a bit about project delivery then. So I've got a timeline at the top there, and that's kind of how we've been working for this pilot plant. So we started installation of the pilot plant equipment back in February this year. We then started process and M&E commissioning in April. That went on till about June and we have been operational since June. We are still operational at the moment, coming to the end of that now, hoping to finish up around November and then followed by decommissioning. So it's not been completely straightforward. We have had a few delays and a few extensions to some of those delivery stages, and you can see those ones in red there. So what I was going to do on this slide was just talk through some of the reasons why we've had some of those delays and some of the learnings that we can take from those delays. So starting off with delays in commissioning. So some of the challenges that we had around commissioning was mainly around health and safety and making sure that our pilot plant was compliant with our regulations. So the biggest one for us was DSIR, so dangerous substances and explosive atmosphere regulations. So this is really important that our pilot plant complies with this, and for all of our pilot plants, we will conduct a DSIR assessment on the equipment and the feedstock to make sure that there are no explosive atmospheres being generated during operation. So we completed our DSIR assessment as we were kind of getting our pilot plant kit on site. The pilot plant, as it arrived from the Netherlands, didn't have any hazardous zones associated with it. When we conducted our DSIR assessment, we did reveal that some of the process equipment should have a hazardous zoning associated with it, and that was mainly due to different feedstocks being put through that pilot plant than had been put through previously, and potentially some slight differences in regulations between the UK and the Netherlands. So to get around those kind of hazardous zones and make sure that our pilot plant is safe, we would have had to make sure that all of the equipment around those areas was ATEX rated. Now, obviously, this pilot plant hadn't been previously zoned hazardous, so none of the equipment was ATEX rated. And in order for us to upgrade that equipment to be ATEX rated, it would have been very time consuming and quite costly and very challenging as well, because some of that equipment is bespoke for the pilot plant, potentially sole supplied in the Netherlands as well. So quite a challenge for us. So we did have to make quite a few modifications to the equipment itself to make sure that we could either reduce or remove that zone without having to upgrade equipment to being ATEX rated. So modifications to process parameters, modifications to the way that the pilot kit was arranged, and nothing that was sort of too detrimental to the process. We did have to drop a couple of temperatures, which hopefully hasn't impacted efficiency too much, but we'll find out as we get more data from our pilot plant. But obviously safety is the priority. And I think the biggest learning for this is if an early desir assessment can be completed before your pilot plant kit has arrived on site, even if it's just a desk-based study, that would be really useful to identify if there are any hazardous zones up front. Maybe whilst your supplier still has the equipment can be upgraded to be ATEX rated, or modifications can be done before it arrives on site to save you time and money on site. So that was the biggest one for us that caused some delays in commissioning. And then I've put a couple of other regulations there as well that we did have to meet. So water fittings, wherever we're connecting into a potable water supply, we have to maintain a sufficient air gap between that potable water supply and our process equipment. The pilot plant wasn't compliant with that air gap, so instead we had to use final effluent, which wasn't too much of a challenge for us because we were conveniently located quite near the final effluent takeoff point. But for some other projects, I think for us going forward, we'll bear that in mind and we'll make sure that we are close to a final effluent point, or that we check before the kit arrives on site that it's going to be compliant with the water fittings regulations. And another one as well, just finally, safe working on site, obviously really, really important. And what we found when we did get the kit arrive on site was it came with kind of leaning ladders that we wouldn't generally consider as safe access to the tops of tanks. So instead we did erect quite a lot of additional scaffolding around the pilot plant, which obviously added a little bit of time and cost to the project. And I think, again, that's just a difference possibly in regulations in different countries or different companies where leaning ladders generally for us aren't safe access, potentially for someone else they are. So just bearing that sort of stuff in mind when you've got suppliers from different countries coming to site, make sure that they're all working off the same safe regulations. Okay, so moving on then to the reasons why we were slightly delayed in operation. So our biggest challenge during operation has been maintenance and maintenance of kit. So we've run into failures of quite a few bits of process equipment, mainly just due to kind of running batch processes. I think the main takeaway for us from this would be make sure that you've got confirmation of an inspection being completed before your pilot plant kit arrives on site. Make sure you've got a checklist, visual inspection has been completed, fat test has been done, routine maintenance has been completed prior to delivery as well, just so you can make sure that all of your critical equipment isn't going to break down as you're running a batch process, because obviously that can cause quite a few delays whilst you wait for spares to be brought in. And that links to my last bullet point as well, is make sure you have a list of critical spares for your equipment and locally hold those critical spares, or if not, make sure you've got a confirmed route of supply, because I think some of our delays from this didn't necessarily come from the equipment breaking down, more kind of waiting for the right piece of equipment to be delivered to site. So that can be a little bit of a challenge, and I think just something to think about quite early on in the project. And then lastly, just generally wanted to highlight again, I think we know this, but it was maybe even more kind of obvious to us throughout this project, was the importance of collaboration. So working internationally with the supplier can be difficult with different time zones, language barriers, but constant collaboration and partnership has really made this project run smoothly. When we have encountered failure of equipment, we've been able to pick up the phone to the supplier in the Netherlands and get that sorted out. We've had them there for guidance for process and operational issues. And when you are running a pilot trial, time is quite critical, especially running a batch process. A couple of days delay maybe doesn't seem a lot, but it could mean that you lose an entire batch. And that's another data point lost on a graph. So having that constant collaboration is really, really critical. And I have put there international shipping, possibly seems a bit random, but something that was a really big challenge for us on this project was sending samples of the product from this process, which is still classed as a waste, to the Netherlands for some specialist analysis to be done. I don't think we anticipated the challenges that came with that. So getting the right documentation in place and making sure that all of the waste classifications have been done to send that product to the Netherlands did cause us a few delays. And for a while we were running without any analysis results, so we couldn't do a lot of process optimization. So I think if you are in a position where you're working across countries and you do want to send things abroad or even send things in again, like I said, waiting for pumps or motors to be delivered to us, just building that extra time for all of the documents that need to be completed. Okay, so those are just some of our key learnings from the delivery itself of the pilot plant. So I'm going to move on now to talking about actual operation. So operation's gone really well. We've been running our cell cap production semi-continuously. So we've managed to make about 200 kilograms a day of cellulose product. You can see there a photograph of the cellulose and hopefully a video of it's working as well. We've done six batches of glucose production so far and lots of sampling. So you can see there all the bottles that we've been collecting. Obviously, as Richard said, a critical part of this project is analysing our material, knowing what's in there. So loads and loads of sampling going on. We're analysing 30 plus determinants. We're working with loads of different specialist laboratories, and we're freezing quite a lot of glucose as well so that we have some saved for future experiments. I think just touching on future considerations, possibly for full-scale operation, we would look at suitability of equipment. Obviously, a pilot plant isn't designed to be super efficient, and that's fine. And I think we can learn a lot from what has failed in the pilot plant and what maybe needs to be designed differently in a larger scale operation, pumps, instrumentation. How could we optimize process parameters to improve our yields? Could we increase temperatures? Could we add more additives? That's something that we're going to be testing during the trial and something that will feed into future design. And lastly, just mitigating any impacts to downstream processes as well. So cleaning fluids that are generated from this process can be quite high pH, which if we returned directly into the inlet channel, particularly at a larger scale, would potentially be a detriment to the downstream biological process. So just thinking about how we would manage things like that in the future. Okay, so I'm going to move on to just touching on work package 3. I mentioned on the earlier slide, I showed the picture of all of the samples that we've been taking, and those are basically to go and test all of these different parameters. So we're testing loads and loads of things for very different reasons. We're testing sanitary determinants just to inform us about how we could use the glucose in our own processes and any load reductions that we're getting through cell cap. We've got some yellow analysis here as well. This is all for end of waste purposes. So testing things like emerging contaminants, metals, pharmaceuticals, pesticides, trying to see what the baseline levels are in our product. There's a bit of text there on the right hand side about the Waste Framework Directive. You have to be able to prove that your product meets legislation and doesn't cause adverse environmental or human health impacts. So that's some of the reasons why we're testing those yellow analysis there. And then finally, we are doing some analysis for process optimization as well, looking at how much cellulose is in our cellulose and what yield of glucose we're getting from that too. And just touching really quickly on some of the challenges with sampling, I think sometimes can seem relatively straightforward doing lots of analysis, but is actually quite complex, especially when you're analysing this much stuff. It's a new material, so getting the right method and matrices is really, really important. Bottle types, preservation and storage. Logistically, when you're sending lots and lots of samples to different labs, making sure that it's in the right bottle type and that it is preserved properly is really important, because we've kind of got a one shot to get this right, and if it's in a slightly different bottle type, that could really heavily influence the results. So just bearing those things in mind if you do have a really big package of analysis work, it's really, really key. So I'm going to move on now to looking at some of our outcomes and data from running the pilot trial, starting with the cellulose recovery side, so the cell cap process. Just got a bit of a mass balance here. The pilot process takes around 250 meters cubed per hour from our Blackburn crude inlet into the process. Obviously that's just crude sewage, just post coarse screening, so it's still got all of the solids in there that we need. So we feed that into cell cap for 8 hours a day. It takes us about 5 days to produce a 1,000 kilogram batch of cellulose. We've measured that to be about 40% dry solids, and data from the Netherlands suggests that there's about 24%, which is actual cellulose fibres. We're still waiting to get some results to confirm that from our trial, but we are expecting to see a similar cellulose recovery rate from bean solids. Some data there around the combined returns as well. So obviously this process is capturing the solids, returning the liquors. We are at the moment from our data seeing around an 18% BOD load removal and a 29% solids removal through that process. So really good load removal there, and you know, lots of potential benefits that come with that load removal. Load reduction downstream, potentially increasing your capacity of downstream assets. More capacity in your PSTs could potentially be repurposed as storm storage in the future. Building smaller assets, so capex savings, reduced aeration demand and OPEX savings. And obviously we're also taking out quite a lot of the solids there, so there's benefits for reduced sludge treatment, handling and disposal as well. And there has been some data from the Netherlands as well to suggest that this process can capture some microplastics, which is obviously contributing to improved effluent quality and supporting regulatory compliance in the future as well. So really promising results from the cell cap process alone, and producing that really valuable resource of cellulose, so 1,000 kilogram batch every 5 days or so. So what we then do is we feed that 1,000 kilograms into the CellForce process, which is a 48-hour batch process. We add some chemicals and some water in there, and we produce our glucose solution off the back of that. So we get about 3 meters cubed of the glucose solution from the 1,000 kilograms of cellulose that we fed in, and a little bit of solid waste that comes out there as well. Again, still confirming the kind of glucose that's present in our solution that we've run at Blackburn, but data from the Netherlands is suggesting that you do get around 75% conversion of cellulose to glucose. You can see that data in a graph there from the Netherlands, which shows that gradual conversion of cellulose across the reaction time as well. So quite a good conversion rate there. In terms of what's actually in the glucose, so this is the expected glucose composition, again, data from the Netherlands. So it is a glucose solution, quite a lot of that, 78% is water, expecting around 8 to 9% of that to be glucose, along with some other components like xylose and some solids still in there as well. Mainly really fine solids that have come through the process, but also some unreacted cellulose and hemicellulose in there as well. So we will be confirming the composition from our trial as well, but still expecting to get around 8 to 9% glucose in there. And, you know, trying to look at if we could potentially increase that percentage as well to be used as a feedstock in some of our future work packages and work package 6. Could it be a feedstock for fermentation, that type of thing. So really excited to see what results we get from this as well. And then last slide from me, so just a bit of our own data here. So this is all data from our trial that we've collected so far. As I say, we've run 6 batches, so we have 6 data points. We're measuring things like COD, solids, BOD, pH, and you can see there some of the variability across the batches. So batch 5 is particularly highlighted in red there because that was where, as I mentioned earlier, we had a bit of equipment failure and one of our motors failed, which meant we actually transferred less substrate into that batch, and you can see the results there are kind of respective of that. COD is the most variable result we've seen so far, and we think we can use that as a good kind of surrogate for glucose measurement. I think that there will be a loose correlation with that. And that's one of the ones we are most interested in. Richard mentioned that we would be looking to use this potentially in our own industry. So could we use this as a source of carbs to aid the biological nutrient removal process as a methanol or an acetate substitute? So it's really promising to see the high COD results there, because we think that could potentially be a really good source of carbs for us to use in that situation. Solids is quite variable. You know, so they are still relatively high. But in terms of percentages, as you saw on the previous slide, not too much in there. And then BOD and pH have been quite stable between our batches, which is good to see. And we are going to be collecting more data as well, sort of metals and some of the other analysis that I mentioned on the earlier slide as well. So we'll be able to get a real profile of batch variability. And we're hoping to get to about 8 or 10 batches, and that should be enough information for us to start drawing some conclusions about potential markets and any pollutants in there as well that might prevent us from getting end of waste status. So that's it from me. I think I'm now handing over to Richard to close out.
Oh, right, wonderful. Oh, thank you very much, Francesca. So hopefully you've heard as much as what we've got for you with regards to biopolymers and circular economy, and very specifically around work package 2, cellulose and glucose recovery. this morning. I just wanted to really go through the next steps. What you've been presented with this morning it's a very complex project. Okay, Francesca talked about the range of analysis that needs to be done. I've spoken to you about the geography of the project, the fact that we are very much an international project. We've had lots of fun, or we are having lots of fun out on site doing our science and engineering, but it brings us to our next steps. What do we need to achieve next? And it really is about those uses of biopolymers. Where are we going to? So first of all, it's about yields. Okay, understanding what glucose we have, what glucose can we extract, and also what the levels of CalMera we can extract from different sludges. So over the coming months, we'll be learning a bit more about those yield rates, what offers us as a water industry the higher potential for biopolymer production. And then once we understand that, we'll be looking to Yara and to Brownfield to help us understand what those agricultural uses are, and making sure we understand the yields and the growth rates within the agricultural sector over the coming next 2 years, so that we can report back to you, help you understand what the true kind of positive impact is of what we've been doing within this off-water project. And we'll look at bioplastics. So our friends at CPI are going to help us with our glucose, see if we can replace any of those fossil fuel-based polymers within the production of bioplastics, and then P removal as well in our wastewater treatment system. Exactly what Francesca said at the end there. This is a really big opportunity, given those nice high COD levels. Let's see whether we can use that to our advantage as water companies and really have a true circular economy solution for us all. That's all very well and good, but there are some commercial aspects and commercial areas we want to go into which are clearly covered by current legislation, and we need to align to that. So we've got a lot of work to do with our colleagues at WSP with regards to the end of waste status for all of those different uses. We can get those right and for everybody, and we can get the right answer from a national viewpoint, but it really does open the door up for all of those great opportunities for water companies and those receiving industries. How do we help them to decarbonise as well? And it brings me back to the value triangle there on the slide, which we introduced earlier on. Where should we be as water companies? Should we just be concentrating on the agricultural uses, or should we be adding the middle of the triangle to our opportunities, and even the top, the higher level opportunities there? Where should we stop? Where should we stop with regards to refinement of the biopolymers, whether that's CalMera, whether that's glucose? Where do we find is a sensible position along the production curve, if you like, as water companies before we hand this on? The key thing to get across is this is a worthwhile opportunity for the water industry wherever we take it to. It really does open doors, but for all of us within the water industry and outside. If you'd like further information on what we're doing, as and when it's developed, we plan to put it into 2 places. First of all, there's an area on the United Utilities website where you can go to and catch up on what we've been doing. And then we'll also have a portal on the Spring platform as well. That's where we'll put our technical reports and then some of our other outcomes, our documented outcomes, so that you can take them in, absorb the information in your own time. Please get in touch with questions off the back of that. We'd love to answer your questions, just to be able to get us on email and so on and so forth. So do get in touch. And the guys, I think the Spring will obviously upload this video with all the showcase materials as well. Looking to the future a bit more, Francesca will have a poster up at the European Bioresources and Biosolids Conference at the end of November. So if you do see her there and you see her poster, please vote for it. Very, very important. But also do say hello to Francesca. And just if you've got any questions about biopolymers and circular economy, there's an opportunity there to just have a face-to-face chat around those questions, and hopefully we can get some answers. And then finally, we do plan to do more in the way of another Spring showcase around the CalMera, so around the work package one element of biopolymers in the circular economy. We just need to get our plant up and running start getting some data in. Once that's available, we'll come back into this forum and let you know that. So that's it from me. Just say thank you, obviously, to my co-presenters. Thank you very much to everybody involved in the Biopolymers and Circular Economy project so far, all those organisations that I introduced you to earlier. It is a really complex piece of work. Everyone's working very, very hard to try and get those outcomes. So congratulations, everybody, for getting this far, but there is still a lot of work to do. Thank you. Have a nice day. Over to you there.
Great, thank you, Richard, and thank you so much to all of our presenters so far. It's been a really informative and great presentation. Do keep putting your questions in the chat as we head into the Q&A portion of today's session. We've had a couple come through and a couple come through privately as well, but do keep popping those in as they occur to you. I'm going to stop sharing the screen now so you can see the lovely presenters a little bit better for the Q&A, which I'm sure they're thrilled about. Bart and Yemi, if you could please pop your cameras on for the Q&A as well, that would be great. There we go, thank you so much. So, yeah, come on in. Come on in. I'll go with me, yeah.
Oh, hi.
So, first question is for Yemi, sorry. Are there existing examples of commercial implementation of the biopolymers you'll produce in Blackburn already?
Yeah, good question. So yes, of course, we are looking towards that. We're looking for the glucose. So there are lots of demand over there also to do some testing with the glucose. But first we need to do some trial tests. So I think that's what we're starting with. We're making first samples. We are sending to different companies which want to do trial tests with that. That are also different large companies or commercial companies.
And I'll just add to that. We want to add to that. We want to, it's a case of where opportunities come along, new opportunities. The more people we talk to about this, the more opportunities are coming our way. It's just to understand how we can use biopolymers. So where Emma just spoke there about glucose, and when we talk about Calmera and as a biopolymer, there's already been work done in the Netherlands where Calmera has been used in products. So there's already opportunities there which we can convert into a UK market. So we'll keep talking about it. We'll keep banging the drum, and more opportunities to use the biopolymers in everyday items.
Great, thank you, Richard. And the next question, I think maybe for you as well, Richard. What's the market demand like for biopolymers from wastewater?
Right, okay, that's a great question. Right, so what I can talk about is the opportunity. Okay, and I think it was on my earlier slides actually. Fossil fuel-based polymers been used in around, it's $125 billion of items every year. Okay, so I'm not saying that biopolymers are suitable to swap out for $125 billion per year, but it gives you a taste and a sense of how big an opportunity there is for us. So even if we were to replace 5% of that, it's a case of, it is a large opportunity to use fully sustainable biopolymers in place of those fossil fuel flares. So maybe not the direct answer you'd like, but there is absolutely opportunity out there, and we should all have a look around, look at the everyday items that you're using and think, oh, could that be an opportunity for lesser bioplastics?
Great, thank you. Next question is from Phil, and I think it might be for you, Bart. Has an increase in polymer consumption been observed in the site's sludge process since it doesn't contain the fibrous material?
Yes, a good question. So this is actually something that we've been that we followed in the past for two reference sites that we have in the Netherlands, and over a year, we saw that there was actually no tangible decrease in dewatering performance, or so. To simply answer that question, we've not seen it happen.
Great, thank you. Is there anything you want to add to that?
Not at this stage, no. But obviously, as we learn more and more, we're right in the middle of it. Project. So as we learn more about it, I think we will be able to answer more of these questions in this.
Perfect. And then next question from Chris, I think for you, Fran. Was there any analysis of COD fractions within the glucose project?
Okay. At the moment, we haven't done a specific analysis of the COD fractions. We've just done the COD analysis, but in work package 4, which is the water industry uses of the glucose, we are planning to do that piece of analysis so that we can understand whether they are fractions that can be used in the BNL process and what the actual breakdown is. So we're hoping to get some specialist laboratories involved with that can do that analysis for us, because that would be really useful.
That's great, thank you. Great, so next question, what has been the biggest challenge on the project so far?
Well, I can say from an operational point of view, I think, well, I kind of touched on them already. Desire definitely has been a big challenge, not just because of the modifications that we had to make and the kind of extra cost and time associated with that, but also the kind of then operational impacts of the desire mitigations that we put in place. So an example being we had to open a lid of our cellulose hopper to make sure there wasn't biogas built in there, but fortunately, being in the UK, a bit of rain got in that hopper, made our cellulose a little bit wetter than we would like, which then kind of made it more difficult for us to transport that cellulose into the next stage of the process. So just unexpected things like that obviously with best intentions trying to make the process safe, there's then some that makes operations slightly less easy, but that's been a challenge. And then I think the other one would be permitting. Because we're dealing with something that hasn't got end of waste status yet. I mentioned the shipment, so it's quite challenging to make sure that you've got all of your documents in place for shipment of a waste sample. And I think for the other pilot plant as well, just kind of understanding what's required there too. It's quite challenging, the waste permitting side. So that's for me.
For me, just look, it's innovation again. So it is difficult to deliver. It's not it never straightforward. You're dealing with quite often temporary systems that you're trying to put in place into an existing process. So always got the technical challenges of that contractually. Okay, we don't know whether we're going to get the outcomes that we're looking for. Okay, we really don't know whether it's going to be a positive or negative outcome. So trying something for the first time. So when it comes to getting into contracts with different organisations, it can be a bit tricky because you haven't got what the end product is likely to be. So there are quite often discussions around how best to contract within innovation projects. Quite tricky. You mentioned permitting, just the general kind of geography that we're dealing with within the project as well. We are an international project. We're working very, very well as a collaboration. There's always complications when you're maybe trying to import and export different bits and pieces now. You need to build that time into the project for all of these complications now. Fortunately, the days of innovation projects just turning on site, plugging something in and letting it run, they're long gone. There's a lot more around the periphery of what you're trying to do with an innovation scheme that really does need to be done, just to make sure that everyone stays safe, everything is done appropriately for the context of the project. Okay.
Absolutely, thank you so much. Bart and Yemi, from a supplier perspective, do you have anything that you would like to add to that? Do you have any sort of challenges that you in particular faced, especially being, internationally? Is there anything spring to mind when it comes to challenges for this project for you guys?
Yeah, of course, there are all kinds of different challenges in there when you're starting up. So all simple things, but I think most of it already is mentioned. What we haven't thought of, that's the problems you occur, but also quite necessary for us to learn from it, to don't make the mistakes twice. So that's really helpful, of course. Also with upscaling of our process, we already know some things what we did the right way, so we can improve that. So I think that's really helpful, and also really helps that we're doing at different countries to see, okay, there are sometimes some different rules in there. So that also helps, and it also helps to see, okay, what's the glucose we can make? What do companies say about it? Do they like the quality? Can we improve it? Should we improve it? So I think, a lot of learnings has been already been made and are going to be made in the following years.
Great, thank you so much. Some good insights. Great. So the next question is, are there any patterns to cellulose load coming into the treatment works, and how could this affect operation?
Okay, so yes, there are patterns to cellulose coming into the treatment works. We have kind of experienced a diurnal profile to that. So at Blackburn, I don't know if this is unique to Blackburn, we get a very high cellulose load around midday and almost nothing until midday, which I guess makes sense if you think about people flushing their toilets. But it does cause us a few issues on operation, because we're then producing a load of cellulose all in a short space of time, and it's quite dry material, mentioned about 40-45% dry solids. It can sometimes overwhelm the equipment there, so pumps, motors overheating, tripping of certain equipment. So I think that's something we didn't expect, is that diurnal profile, and something we would have to think about in the future. Could we potentially buffer it in some way before it arrives at our treatment works? Could we collect it in a buffer tank before, or do we just need to upgrade some of the equipment to make sure that it can cope with those really high loads?
Interesting. So high customer demand can interrupt the process. Yeah. Oh, great. Thank you. And what would be the challenges with scaling up this type of technology?
Okay, for me, it's about commercial business case. Okay, so what are the yields? So I've said it before, that we're right in the middle of an innovation project at the moment. We need to understand what the yields are from both camera and for the cellulose and for glucose. Once we understand that, then we can look at the commercial business case, understand how that stands up in the real world against our other uses for sludge. So it really is, that's the bridge we've got to build, I suppose, make sure we understand what the commercial case is for this, and that's very much part of the latter part of our.
I think just but like OPEX, is it worth it? You know, we are measuring things like chemical usage, water usage, power, but we're doing it on a pilot scale. So obviously then that scaled up on full scale, and is it worth it with the refinement steps in the future to be adding all of those chemicals to produce the glucose?
Absolutely. Great, thank you. So someone else has asked, we saw a feature on the BICE website on the process referencing glucose sugar. Any thoughts about where you would use this?
Yes, absolutely. So then, obviously, the glucose is coming from a wastewater source. Okay, it is absolutely. So we can't go into the food and beverage market. Okay, pharmaceuticals, industries such as that. So when we talk about the opportunity, I mentioned $125 billion of fossil fuel-based polymers. You know, pharmaceuticals just come less, so does the food and beverage market. So clearly, we can't go into that area without a significant amount of refinement. So that's not a focus area for us. So that's the answer to the question. We're not going into any areas that could potentially cause harm to anybody.
Right. We have just got one more question coming in. We've still got 20 minutes left, so if anybody in the audience has any questions they'd like to ask, do make sure to pop them in now. The next question is from John, who has asked, this is a substantial project with significant time and cost challenges. How do you manage this, and have you had any past learnings that help to mitigate the risks?
Oh, right, okay, another one for me. Well, thanks for your question, John. Okay, yeah, you're right, it's a large project, isn't it? £6.8 million, 90% of it is coming from the Off-White Innovation Competition. I think it's the largest project that we've got on our current programme within our UU Innovation Programme. How do we manage this? Well, we've got quite a detailed kind of governance structure with any of our innovation projects. So we work through what's a four levels of governance. I'm worried I'm going to bore people. But key point is that we're at the, say, governance level 1, we're developing all of the work, we're developing our deliverables, we're making changes within the project. All of those elements go through our checking and approval process, and that involves a steering group. And that steering group are the paying members, all those paying organisations that I spoke of before, Brownfield, Yara, South West Water, Severn Trent, and others. Okay, so they're our steering group, and they're there helping us to make sure that this large project is directed in the right way. And at some stages, given that we are a 4-year-long project, at some stages we will have to alter that direction, and that's why it's really key that we have a named member of each organisation on that steering group to help us deal with those changes, which could be very, very good for our projects. Don't ever go away thinking that the changes are always bad, because they're not. It might help us something might happen in the wider world, and we just need to redirect and flex, if you like, to align to that. So I just say that's how we manage it. We manage it within our governance process, within the steering group. And you mentioned past learnings there. That's just something that we've developed within our United Utilities Innovation Delivery team since we started on WBC1 back in LP. When we did that proposal, we brought that way of working together, and we've had no need to change it so far. We might change it in the future, but at this moment in time, there's no need to change it. It's worked well across all of our successful projects, which have been a few. I'll put them wrong.
Great, thank you, Richard. And are there any kind of critical blockers to wider adoption from a regulation or approval perspective for this project?
So I think I'm interpreting this in terms of use of the glucose, because I think integration of the pilot plant wouldn't, except for the reasons we talked about full-scale design, wouldn't be too challenging. I think it would be the adoption of the glucose in final products, which would be the challenging part and the critical blockers. It's really hard. So we've got a whole work package on end of waste where we're looking to figure out what the requirements are for us to meet certain applications. It's hard for us to know what the product needs to be before we know what our market is. So each different market application for glucose will have a different set of requirements that will contain limits that your micropollutants or whatever's in there need to be within this limit. But obviously, like Richard said, it depends on what market you're going into. If we were just going to use it within our own water industry, those regulations will be a lot more relaxed than if you were going into a packaging industry or sort of like plastics industry. So at the moment, we're just doing a broad range of analysis. We're using guidance from WM3, which is one of the end of waste documents that tells us what sort of things we do need to be looking for. So we're just going to get a really good baseline of what's in there. GCU are doing a non-targeted analysis for us, which can identify peaks of common pollutants that we would expect to find from sewage-derived materials. Once we've got that baseline, we can then use it to understand, actually, we maybe can't enter that market because we have far too high levels of this particular thing in there. But I think that will be the main blocker, and it will be it will give us the direction in terms of where we go with our product.
Well, what I just say there, just drawing on the regulation/approval perspective there, but this is all new to everybody. Okay, it's not like we go off to whoever's regulating the outputs, as Francesca was describing there, or even regulating our work on site. They don't know about it. We're learning, they're learning. So everyone is learning how to deal with new things all the time. It isn't that we're repeating something that somebody else has done, how to block better wastewater treatment. So it's understandable that people are a bit unsure about how we're doing things. But the great news is people are asking the right questions, and that's really, really positive for us. So people are asking the right questions. We're hopefully providing the right answers. So it's a case of, everyone is learning how to adapt to these new systems, these new ways of working, creating new and different uses for biopolymers. Okay.
Great, thank you. So the next question from Steve is, do you foresee any key chemical supplier impacts if this is successful?
Right, okay. No,
Go for
it. So this is why we have Solenis and SNF as organisations within our advisory member group, Steve. They're there because they've seen from their fossil fuel-based polymers that they provide into the water industry, but it's not completely sustainable. Going forward, they do have to think differently about how they do things, and this is an opportunity for them to do that. So for having them as advisory members, helping us understand what their specific needs are with regards to raw materials within their existing polymers, We'll see whether we can switch some of them. I can't promise all of them, but just some of them out with our biopolymer variant is a great way, good example of how you go about how to answer your question. Is there anything else you'd add to that?
Perfect. Next question, I think one for you again, Richard, is are there any similar related projects to this that are going on across the sector that you could collaborate with? I know, for example, we're going to be hosting a showcase in a couple of weeks with Ambient Water on their HDO water treatment project. Is there any kind of opportunity?
Yeah, and it's across the sector is the funny bit for me, because when you look outside of the water sector, you look towards the university, so particularly Cranfield University, they're looking at other ways that we can use biopolymers within the agricultural sector, within soil chemistry. So we get a lot of invites from them to kind of join up our thinking and collaborate a bit more outside of the project. Okay, so that's a key thing. Obviously, the work we're doing around cellulose, okay, overlaps with some work that Severn Trent have already done, and that's why they are a steering group member on this project, and we're able to share our operational learnings with them and vice versa. So we're able to overlap, and that overlaps with some of the work that they're doing in their net zero hubs or outside of this project. So lots of opportunity is what I say to collaborate. If people have ideas and want to approach us, please do get in touch so that when we can see how it all fits together. It isn't just about the UK water sector. Okay, it's about other sectors as well, and how we help them to do that.
Okay. And that's really the best part of circular economy, isn't it? It's not just within water, and everybody involved.
There's the boundaries, eh?
Yeah. Great. And then next question from Sue is, what are your biggest, oh, sorry, I think this one's for Yemi. Yeah. So, speaking from a supplier perspective, especially being an international supplier, not just with this project, but with the wider water sector, what have been your kind of biggest challenges with coming into the UK water sector? That one's for Yemi and Bart.
Mm-hmm. Yeah, it's a good question. So I think there are several points. So we, of course, experience with the Netherlands, water boards of the Netherlands, and I think there are a few differences. So what we saw, at least for the rules in the UK, were different. So I think that was our first challenge to make sure, okay, why are the rules different than in the Netherlands? So we have to improve our process also to get working with the right rules. So I think that was the first challenge. But I think it's also maybe easier to work with the UK, because you have quite a lot of wastewater treatment plants. You are other regulated than the Netherlands, so that's I think better, or at least easier than how it works in the Netherlands. And of course the challenge is that the UK isn't in the EU anymore, so that gets some other challenges over there. But I think so there are some challenges, but there are also some upsides working with the UK, I would say.
Perfect, thank you so much. Great, so the next question is, have you found working on a collaborative off-what project? Oh, sorry, how have you found working on a collaborative off-what project as an SME?
Yeah, I think it works fine. So it's a nice big collaboration. So Richard talks a lot about the different partners we have. So I think we learn a lot on that. I think the project is also working quite well. So yeah, no, it's working quite well for us as a small SME for sure. Yeah.
Brilliant. Thank you so much. And then our last question from Amy is, do you consider cross-contamination between batches?
Well, so for us on site, there's quite an extensive cleaning process that happens between batches. So we clean down with caustic solution all of the tanks. So I think we mitigate cross-contamination from the process. From sampling, everything's bottled separately and stored far away from other batches. So I don't think cross-contamination is an issue for us on site. I don't know whether on a larger scale it will be more challenging. I mentioned the washdown system is quite high pH, so how you manage that at a larger scale might be challenging. I don't know whether Emma has any comments on whether they do that, whether cross-contamination is an issue for you.
Mm-hmm. Yeah, so again, so of course, so the contamination is quite important, of course, for us. So we also changed our process on bigger scale if we look at the pilot scale, so we are adding some processes to make sure we don't have any contamination. But as you mentioned, we clean after every process, so we don't have any contamination, or at least we manage that.
Great, thank you so much. And speaking from a UU perspective, do you, obviously the next kind of stages of the project is to almost scale it up across other wastewater treatment plants. Do you foresee any challenges with that? Or?
Again, look, it comes back to what we learn over the next 6 months or so, as to how we go about upscaling these systems. Clearly, when you look at what Bart and Emma and Francesca have been through with us this morning, you know, we can break the cellulose system out from the glucose system. So we can look to see where we can use cellulose recovery more widely across our asset base. And when it comes to the upscaling of glucose, there's a bit more work to do there. We need to understand what those percentage yields are, what our glucose extraction looks like, and then maybe it's more of a centralised system that we look for and look at glucose. But so we can break it down into the component parts and use them differently. As for Calmera, we have looked in the past at a business case for Calmera to have a centralised Calmera production plant. But again, look, it comes back to those yields and what of this project as to whether that commercial case really does stand up to
Absolutely. And I know as a company, you are very much forward-facing with your innovation, very mature with your innovation offering. Do you foresee any challenges with introducing this to wastewaters as in the teams that actually work with those wastewaters? I know sometimes local teams can be a bit more resistant to innovation and new kind of challenges coming in.
We're always developing, we're always learning, we're always looking for opportunities to improve things. And with that comes an amount of an awareness of training. Okay? So we need to, wherever we go, we try and involve our operations teams as much as we possibly can. Make sure we're getting early sight of exactly what it is we're doing. And if this does become a reality and becomes more widespread, then obviously we have to train people and make sure they understand exactly what to do.
Absolutely.
But equally, not just for day-to-day operation, but what it means for that wider industry and beyond, and what it is they're helping to achieve on that much more broad strategic goal scale.
Absolutely. It's really just about the communication and making sure everyone understands, and yeah, absolutely. Great. Well, I think that brings us to the end of our Q&A session, unless any more questions come in the next couple of minutes, but I will start closing it off now, if not. So thank you so much again to all of our fantastic presenters today. It's been a really, really great presentation, and I hope the audience has found it really, really valuable and has some fantastic knowledge to take away from today. I know I have got some new knowledge from today. We will be putting the poll in the chat again, so just another reminder to please fill that in. It really does help us shape these showcases and make sure that we are delivering the most value to our audience that we possibly can, and that they're landing in the right hands as well. If there's anything I can do, anything Spring can do to help you understand the subject more, or work with you to take that knowledge back to your organisation, please don't hesitate to get in touch. I know Richard, you're happy for people to get in touch with you as well, aren't you, with any questions? So absolutely, please get in touch if you do have any further questions or anything that could be helpful in helping you progress the adoption of this in your own organisation. We will be putting the recording of today's showcase on the Spring platform, which was linked in the chat too, along with a written case study. That should hopefully be available within the next couple of weeks, but we will post it on our LinkedIn when that case study is available to view. So make sure to follow us on LinkedIn and you'll see when that is ready to view. Just want to say a final thank you again to the presenters and to all the audience who joined us live today. Thank you so much for taking the time out of your day, and we really hope you found it valuable. Thank you, everyone. Hope you have a lovely rest of your day. Bye.